Hello, my name is DJ and I'm learning about clustering by experimenting with Raspberry Pis. In the previous episode, we found the Pis on the network. So I've got 4 Raspberry Pis in a cluster here, all connected via Ethernet, power over Ethernet as well. We've booted them up for the first time by inserting the freshly created SD cards with Raspbian OS on. And effectively in the previous episode we used Nmap first of all, but then ultimately we used ARPscan to find the IP addresses and also the MAC addresses of these Raspberry Pis, specifically of course of the Ethernet network interface cards here that we can see. So we've ended up with a nicely configured vars.yaml file with the MAC addresses 95, 77, 44 and E3 for each of these Raspberry Pis, and the 2B host names Bramble-Weenie 1 through 4, and the 2B IP addresses 12, 13, 14 and 15 that we want these Raspberry Pis to have. There's also here a DNS name servers variable pointing to my Pi hole that I want these Raspberry Pis to use for their DNS resolution. There's the details of the ARPscan. So let's now switch to what we're going to do in this episode, which is to do a little bit of initial configuration of those Raspberry Pis remotely using Ansible. And a lot of this information comes from Jeff Geerling, and I've got a link to his networking setup blog post and GitHub repo there. So basically, as well as the vars.yaml, we've also got our inventory pointing to the current IP addresses, the ones that have been assigned by the DHCP server, some random IP addresses, so at least we can reach them. And what we're going to do is use Ansible and specifically connect to them via Ansible using SSH. And so we'll see what we need to do on that journey. So right now, just to confirm, we've got here our vars.yaml file, and we've also got the main.yaml file, which is the main playbook that we're going to be running to configure these Raspberry Pis. And that main playbook is in Jeff Geerling's GitHub repo. And here is also the inventory with a name for the group of hosts I've called Bramble-Weenie. I've modified Jeff's configuration to suit this particular home lab context here. And all we've got so far in terms of any sort of variables, we've got this Ansible SSH user, and we're going to use the user Pi because that's the default user that's on a freshly booted, freshly minted Raspberry Pi OS. Setup. Okay, let me just move my camera over here so we can see what we're doing, and let's get going. So the first thing we want to do is described down here, which is basically just try and run the Ansible playbook, the main.yaml. So let's just do that right now and see what we get. So if we say Ansible playbook, even using the host described in that inventory file there. Am I in the right directory, by the way? No, I'm not. Raspberry Pi setup networking got inventory. Yes, there it is. Okay, so Ansible playbook inventory, and we'll use the main.yaml playbook, and we'll see what happens. By the way, I'm running all of this on my super low powered Pi Model B. You can see the host name there, and that's this machine here. It's an original Pi Model B, so it's quite slow. So we'll see how we get on. So what we notice is that when we run the playbook, Ansible is using SSH to connect to each of the hosts described in this Bramble-Weenie inventory group here. But what's happening is that we're getting a message: the authenticity of host 47 can't be established, the authenticity of host 15, 158, 125. So every single host here SSH is saying basically, I'm not sure about what this host is. I don't really know much about it. And that's the default. I'm going to Control C this, and we'll get a few more weird messages here. But that's the default operation of SSH, which is what you want because it's secure. And because we haven't connected to these hosts before and said, yes, we accept that this is the right identity of this particular host, that's what we get. Let's try that individually, for example. So if we say SSH pi at 192.168.86.47, which is the first host in the list, we get exactly that message. I'm going to say no for now. Well, in fact, I'm going to say yes for now, so we can see what happens. But before I do that, let me open up another window in tmux and just show you what's in my ssh.sh folder in my home directory here on the Pi Model B. I've got a set of authorized keys, which is a collection of public keys from other hosts on my Homeland network, so I can SSH into this Pi Model B nicely and comfortably. I've got some configuration, which is not really relevant for this, and I've got the public and private key pair for this particular machine, and that's all I've got so far. So let's go back and say yes, we do want to connect. What happens is that SSH then says, okay, well, I'm permanently adding the identity for host 47 to the list of known hosts. Okay, and that list of known hosts, if we have a look at that folder again, that directory again, we'll see that it's now created a file called known hosts and put in the identity of the machine we're just connecting to into there. That means, I'm going to cancel actually logging on. That means that when we run the SSH command again, we just get the request for the password. It knows about this host now. Okay, so that's the first problem that we need to solve when we're using SSH with Ansible. So to demonstrate how we're going to solve this, what I'm going to do first is remove that file so that when we do connect again, we're back to where we were. And instead, we're going to use an option, strict host key checking equals no. So this is saying for this particular invocation of SSH, don't bother checking the host key. And what that effectively does is bypass the, oh, are you sure you want to connect to this? I don't know what it is. It will automatically put it into the list of known hosts and then of course prompt me for my password. So now that means that if we have a look in SSH again, it's back again. So we can use the option to say strict host key checking should be turned off, equals no. And we can actually configure that in the for Ansible in the inventory file. So let's just do that right now. Again, let's just reset to where we were. Let's just remove the known hosts file again. So let's go and edit the inventory file and add that option right now. And over here we've got the configuration that we need. Ansible SSH common args equals -o strict host key checking equals no. So we'll save that, and now not only will Ansible use the user Pi to log on via SSH, or try to at least, it will also use this particular option for SSH so we don't get that issue. So let's try that again. If we say Ansible Playbook for this inventory main.yaml, let's see what happens now. So what we get is not the issue that we had before, that's now resolved, but what we get now is failed to connect to the host via SSH, because of the strict host key checking equals no, we now get this warning permanently added that host name 47 to the list of known hosts. That's fine. But what we get for each of the hosts, we get permission denied. Why do we get permission denied? Because yes, we're trying to authenticate with the user pi, and we know, in our heads that the default password is Raspberry for freshly minted Raspberry Pis using the Raspbian OS or the Raspberry Pi OS. But of course, we're not supplying the password, so we're getting permission denied. And a better way to SSH to a host, rather than use a password, we can use a public key. So the next thing we want to do, as described here as well, is we want to use our public key that's on here for this user Pi on Pi model B to authenticate and log on to each of the 4 Raspberry Pis. But of course, we need to get the public key across to those Raspberry Pis and effectively have that public key stored in their equivalent of the .ssh authorized keys file, so that when we're trying to connect via SSH, it will use the public key and everything will be fine. So it's a bit of a chicken and an egg situation at the moment, because we need to send the public key to those Raspberry Pis, but of course we need to authenticate. So we need to use, first of all, a module. We can use an Ansible module, the authorized key module, to send over the public key id rsa.pub, and that's this thing here, this file. We want to send this file over to each of the Raspberry Pis. So let's try that. In fact, let me just copy this and create a file called set sshkey.yaml. That's cat into set sshkey.yaml. We'll put that in there. So let's try that. Ansible Playbook, same inventory file, inventory, and we want the set sshkey YAML file Playbook. But what happens, as we could guess, is that is failing as well, for the same reason, effectively. Failed to connect to the host via SSH, 47, permission denied, public key, password, unreachable equals true. We can't send our public key across because we still can't authenticate. We're still not sending any authentication information for the initial, almost like for the bootstrap authentication, let's call it. And that's described in the blog post here as well. And we can use instead the SSH pass command. What the SSH pass command will do will allow us to supply a password with the -p option, and the password we'll need to supply for each of the hosts, of course, is Raspberry, because that's the initial password anyway. And what SSH pass will do will then run the subsequent command that's specified in a dedicated TTY, so that SSH will be able to read that password from that sort of pseudo TTY and authenticate via the password for that particular instance. So let's do that. Let's try that first, as we can see here. SSH pass, which I had to install explicitly with apt-get install. So if we specify the password Raspberry, '47, we'll see we've got into that machine. So we've now successfully SSH'd to that machine using the SSH pass to supply a password to SSH. So we can now do that with Ansible, because Ansible has a special option to use SSH pass, and that option is -k. So let's try that again. Let's Control D and exit out of there. So let's now use that SSH pass feature with Ansible Playbook with the -k option to ask us for a password that it will then use with SSH. So if we say Ansible Playbook -k, please use SSH pass and ask us for a password first that then you will use. For the same inventory file and the same YAML file, let's see what happens. So first of all, we're prompted for a password, which is going to be Raspberry. And now the playbook will proceed, and that password that we've supplied will be used in the same way that we used SSH pass to provide a password to our SSH command directly. That will be used in the playbook now to connect to each of the 4 Raspberry Pis here. And the playbook, remember the playbook that we're doing is we're using the authorized key module to send over our public key, the public key for the user ID Pi on this Pi Model B, over to each of the 4 Raspberry Pis, so that we can then SSH using the public key without using a password. Okay, facts gathered, and now we're into the task set authorized key. So let's see what happens. Nice. Okay, so far so good. So now we've got our authorized key in there. So that is effectively this thing here, ID rsa.pub. Of course, we've got the known hosts now, and in fact, if we have a look in the known hosts, we'll see that there are 4 entries for the 4 Raspberry Pis. Okay, so everything is now nicely set up to be able to SSH into 168.86.47, for example, straight in, without any password, because we're using our public key. Okay, so far so good. So now we can try and run the main playbook again. So let's see what happens when we try that. Let's do it over here. Ansible Playbook. We don't need the -k again. We want the same inventory, obviously, but we want the main playbook. So let's run that now and see what happens. Okay, so as we can see, as it's described over here in the blog post as well, Ansible is now successfully connecting to each of the Pis using the public key that we've set up now, and also using the default user defined in the inventory file as well. Remember, that was Ansible default user Pi. So let's see the playbook run through. Okay, so facts are gathered, and now we're going through the tasks described in the playbook. So let's have a quick look at the playbook itself over here. It's that one. So we can see that it's got a few tasks, setting the current MAC address there, and then setting the current MAC address, setting the variables, setting up the network related files, and so on. And it also creates some notifications which then cause other actions to happen. So let's just see what's going on right now. So there's the first task, set the current MAC address for F0 for the Ethernet network interface card. Setting the variables, so that's exactly this thing here, set the variables based upon the MAC address. So this is just setting some variables that will be used elsewhere, including, for example, in this handler here, cluster host hostname, but also used in these template files, in these Ginger 2 template files. So let's see how it's getting on right now. Okay, great. So the set up networking related files. So on each of the hosts, it's processed the etc hostname, etc hosts, etc resolve.conf, and finally it should be the dhcpcd.conf files. There we go. And now, of course, we have some handlers. So updating the host name. So as we can see here, here are the handlers. Update host name, and that's going to run the command hostname cluster host hostname, which is a variable, which is from here, which is from the mapping we have in our vars.yaml. So setting the host name to brambleweenie1.lan, brambleweenie2.lan, and so on. And of course, the other handler here that's going to be triggered is the removal of the current DHCP leases. So let's see what's going on. Update hostname, deleting the leases. Okay, it's looking good. Let's let it finish and see what happens. It's finished. Great, so that is more or less it. We've now managed to use Jeff Geeling's networking setup playbook, the main.yaml, through a little detour looking at what SSH, or how SSH is used by Ansible, and learning a little bit about what SSH does when initially connecting to a new host, how to supply a public key for credentials for authentication via SSH rather than a password, how to get Ansible to ask us for a password and supply that to SSH effectively internally as a temporary measure. One thing we should really do as a cleanup is, of course, from a security perspective, remove this sort of strict host key checking variable, just in case we run this again. Oh, I opened up the wrong file. Where is it? In the inventory, in fact. There it is up there. There we go. So let's remove that for security purposes. And that's more or less it. Now what we can do is reboot the Raspberry Pis because we want them to, come back up again with their new IP addresses that we've statically assigned, and the host names and everything all configured. So let's do that as the one last task. So Ansible all inventory. So again, we're still using the same inventory file with the same old IP addresses, because right now those machines still have the old IP addresses, and they'll have those old IP addresses until we reboot them. And let's use the shell module, and the command we want to send is sleep for 1 second, shut down and reboot now. And then let's add a few more parameters. I got these from Jeff, and let's see what happens. Great. So we can see now that that Ansible command, the playbook, has run, or the module command has run, and those Pis should be rebooting. We might be able to see them on the video there. But that's more or less it. One final thing we could do is use ARP_scan again to check for those Raspberry Pis, and we'll see what IP addresses they have now. They should have rebooted by now. So let's see. ARP_scan. Let's use that. What I'm doing here is scanning on the Home Lab network, looking for the OUI for the Raspberry Pi Foundation manufacturer, removing any reference to the Raspberry Pi 4 that I've got behind this monitor, the other one, and let's see. I'm using watch here, but actually we probably don't need to use watch. There we go. So we've got 12, 13, 14 and 15 instead of 47, 15, 158 and 125. Success. Thanks for watching.